Yes, we can.
All
Oh,
right.
and it looks like we're live on YouTube and Twitter, so I think we're good to get started.
Sure. Thank you, Chibi. First of all, welcome back to the CTO office hour. And I have been traveling a bit in the past 2 weeks, so just get to be excited to get back to the stage and talk to all of you guys. So this time around, we're going to share some information about how we improve our token getting infrastructure to get near real-time token getting responses whenever your ownership for certain tokens like ERC20, ERC721, ERC155 tokens, if you change the ownership, like say you transfer a token to somebody else, or somebody else transfer a token back to you, will react to that immediately and perform a reevaluation of the membership in the given community. That will give you the almost near real-time responses. Jump into that. Um, so first, I'll give you a little background. Like when the community admin sets up the token getting rules and you join that community, there are a couple triggers that Collab.Land will evaluate your token balances so that we justify your membership for that particular community. So the first flow is the on-demand flow, which is as a member, you click on the Let's Go button from the Collab.Land join channel, and you either reuse an existing wallet or you connect to your wallet. Whenever that happens, then we will perform a balance check for you. So you will get the corresponding rows with your wallet. If your wallet owns the corresponding governance tokens required by the community, you'll get it right away, and you will see the notification on Discord about the new roles you're getting or the old roles being removed. So that's the first trigger. So you might wonder what afterward. So because when you join the community, then you probably just don't interact with the Collab.Land bot directly from the token getting perspective. So how do we guarantee if you acquire new assets or if you sell existing asset, how your membership will be, updated based upon that kind of events. So we have a brute force background checks happening for every single community, and then we run that background checks periodically at this point. So the interval we run that background check is 24 hours per community, and it depends on the size of the community, and it depends on the active member of the community. It takes a few minutes to multiple hours to finish that background check. So as part of the background check, we basically just check the balance for every single member of the tokenized community we manage and give you the update. So that works in the background. Number three is we try to find the best way to react to the ownership change, right? So of course, like when you own certain tokens on the blockchain, the social truth is the blockchain events. So the multiple events could be relevant to your ownership. One is initially you claim the token, so there's a mint operation. Then of course, like if somebody sell you the token, or you get a token from your friend, from your family member, or you sell the token to somebody else, or you transfer the token to somebody else, those are the meaningful events that will impact your token ownership. Okay? And in the Ethereum space, pretty much all the tokens are relevant to the different kind of ERC contracts. So we have fungible token, which are ERC20, and then we have non-fungible tokens, which are ERC721 and the ERC1055. So the most meaningful event is basically the transfer event. It depends on the contract itself. That could be single transfer event or batch transfer event. And other operations such as a mint or burn, somewhat transformed to the transfer event. It's just the matter of the from address and the to address. For example, for the mint operation, usually the from address is the zero address, and for the burn operation, the to address is the zero address, right? So with this context, I'm going to show you some metrics and some of the screens that shows the different things we'll look at here. So let's first go to our OpenSearch dashboard. So we catch some meaningful events, for the different triggers in our dashboard, and I'm going to show you a couple of dashboards here. So the first one is representing the Let's Go flow, and if you look at every single event, there's some information about what's happening there. So, for example, this is a member, and we don't have any role added, remove the user ID. And what's meaningful for this differentiation is we call this as a join command, very much like a user click on the Let's Go flow, right? So that kind of becomes these time series events and showing up on the dashboard. So this is for last 24 hours, and we're getting a lot of role updates upon the Let's Go flow. Then let's switch back to the background balance check a little bit. This is going to be pretty overwhelming. And so as you can tell, we have a cron job, and we schedule that kind of events across the day so that we can iterate through all the communities, all the members, and check each of them. So we do have different things happening here, and this one not only just for the balance check events, but also some of the Discord events, the TGR events. Let me go a little bit specific about that. See what else. So let's just do the community request check. So this is kind of the scheduling of the tokenized communities. Like we kind of iterate through all the communities one by one. Then this is a Telegram, this is a Discord. So those are kind of happening in the background, and we kind of cascade from the community check into all the active members in that community, so that will become the individual member checks there as well. So this is kind of the second bucket, right? So we have a brute force cron job that iterates through all the communities and the members and recheck the balance over time. It's pretty heavy, it's very well overwhelming, and it adds quite a bit pressure to our infrastructure and add a lot of cost to that. So with these different triggers we have in mind, then we really think about what's the most optimal way to improve our token getting experience. And it boils down to, hey, where's the social choose and how we meaningfully detect the social choose, right? So that gives us this idea to do the event-driven approach. And let me show some metrics there as well. Like we have capture of the blockchain events, right? So this shows like over the last 24 hours, what are the different transfer events we discovered, and then we sort of apply the token ownership check and adjust the qualified roles for each of the corresponding members. So just show you one single event. Okay, so this is a one single event showing the different things here. So we have this user ID, and we have all the information. So these kind of events are very much like reactive. Upon the transfer events, then we revalidate your qualification for the different communities. Let's go back to the slides a little bit. So we mentioned now we try to look at the different buckets of balance checks and what are the different nature of the balance checks we're doing, and what's the impact on the system, on the user experience. So kind of going back to the optimization we try to achieve here is like, hey, because the token gating is really try to reflect the token ownership back to the community membership, right? So where's the social choose? So the social choose is on the smart contract. Say if you use the ERC20 smart contract as the governance token for your community, and you define rules, say, hey, you at least own 10,000 Collab.Land tokens to acquire a role, so that role will entitle you to join different channels. Right? So now, initially, when you join that community, we check, oh, you have 20,000 Collab.Land tokens, right? So you qualify. But if you decide to either acquire more Collab.Land tokens, or you sell some Collab.Land tokens, or you give some tokens to somebody else, then your ownership will change on the blockchain. So for this kind of meaningful events, it gets translated into so-called like a blockchain events or logs, and that's where the social truths actually come from. And how do we meaningfully detect these triggers, right? And we have a few different methodology to do so, and we are being constrained by the APIs, by the infrastructures. So we initially have an early version of the implementation that's based upon the polling. So very much you say, hey, block by block on the blockchain, we keep asking the blockchain within that range of blocks, what are the different events are happening. Then we kind of say, hey, within these different events, what are the events relevant to our decision-making process, right? Now, of course, we don't want to repeat the block by block check. So once we finish the block check from A to B, we will save the checkpoint into our Redis cache. So next time, instead of checking from A to C, we will check from B to C, because we know from A to B, we already checked it, and B is the last block we check on these different blockchain events. So we kind of keep track of this progress, and of course that works. But the challenge is, first of all, we have to proactively pull the blockchain, no matter if there are going to be matching events or they don't have any matching events. So we have to make a lot of API calls to the blockchain RPC providers. And of course, that's a cost to us. And secondly, it's a waste, because we don't necessarily find the meaningful events by calling these different blocks. So what's the better way to do that is, hey, what about we inverse the control, right? So if something happens on the blockchain, and if the blockchain can proactively notify us by calling a webhook we expose, so that would be much better, because imagine anything happen on the blockchain, it will push an event to us, and then we can actually figure out if that is relevant to our community, to our members, right? So that's where kind of need to this journey to figure out like, what's the best way to do that, right? So in that context, let's show a couple of pages here to further enforce that information. So so this is one of the transactions happening on the Collab.Land token, and this is a transfer transaction, right? So what we really care is about these transfer events in the logs. And in this case, we have a ERC20 transfer event. And what's relevant to us is these topics. So first of all, we have this address field. So this address field represents the contract address we are interested in, right? So this is the first filter, like say, hey, we look at all the tokenized communities, and we look at all the token getting rules, and they say, hey, what are the smart contracts these communities care? So that will become the first category of the input we will use to filter the blockchain events, which is the contract addresses. The second one is the different events. And on the Ethereum side, so we usually represent that as an array of items in the topics of Ethereum event log, right? And the first one usually is just the hash of the transfer events. And this is very much the transfer event from ERC20. Right? So ERC20 have these transfer events that contains two attributes, which is the from address and the to address. Right? So the next two items in the log is kind of representing that information. So the first one is a from address. The second one is a to address. Okay. Now imagine if we receive a notification from the blockchain side, what can we do with that, right? So first of all, we know, this is coming from this contract. So if this contract is used by any of the given tokenized communities, then of course it's possible that some of the members will be impacted by that transfer, right? So that's the first level of filtering. And the second level, of course, we care about the different events, and we only listen on these certain transfer events, and we ignore other events because at the end of the day, only transfer events matter to us for the token ownership, right? Then going deeper, we need to look at these two additional attributes, which is the from address and the to address, right? So this is the wallet address in a padding format. It kind of prepends a bunch of zeros in front of the wallet address as a from, as a to. So those two attributes are critical for us because when we receive these events, and if none of the members we have actually owns this wallet, either as a from or as a to, then we don't have to do anything, right? So very much we normalize the wallet address from this attribute. Then we do a lookup from our database. Say, hey, for this from address or the to address, does that happen to be one of the connected wallets our members have, right? So that helps us reversely identify who are the members we should check. And of course, for the first attribute, we figure out what communities actually use this contract. So we end up becoming a list of combinations between the community ID and the user ID. Then we kind of iterate through all these combinations and figure out what membership need to be adjusted there. Right? So that's for the transfer explanation here. And kind of going back to the slides again. So when we initially see this requirement and we look at a few different possibilities, one is we look at the EthysJS, right? So EthysJS have some API allows us to pull the blockchain or even use the WebSocket to watch for the blockchain events. But technically speaking, the WebSocket implementation on Ethys is not ideal implementation. It's just very much a simulation of the polling, right? So basically, when you set up a WebSocket connection, and it just basically keep polling and tell you what's happening there. Then we look at the API providers, and Alchemy has been our great partner all the way. So we work closely with them, and we kind of express our requirements and try to figure out what they can do for us. So initially, we will look at the Alchemy API, and the first set of API we look at is called Notify API, right? And of course, they have pretty powerful APIs there, which allows us to set up a API endpoint as a webhook and receive this, different API events. But then we were a little bit disappointed because most of the notification API does not support our use case. For us, we cannot afford watching for the individual wallet addresses because we support millions of connected wallets. So to, set up a watch for millions of wallet addresses without the context of the contract, it's very difficult. It's not going to scale well. So we reached that requirement against Alchemy and say, hey, based upon our investigation, what's a possibility we can simulate the EthysJS event API, but inverse the control, and we can very much use the EthysJS event filter, which give us the ability to watch multiple contracts and also, filter by the topics. So EthysJS have this nice expression to allow us to decide, okay, when we look at the topics, we can support end condition, we can support all condition. So this gives us the possibility to express our requirement, right? And our friends at Alchemy took our input seriously and started to create a new product called customer webhook. So that's where we have this new infrastructure that allows us to set up these webhooks in the form of GraphQL Query, and our friends at Alchemy using the infrastructure to run these queries periodically and give us that feedback as notifications. Okay, so give you a preview of that. It's like if we go to Alchemy and we actually set up a lot of webhooks. So if you see here, those are the different webhooks we set up and update periodically. So we set up some webhooks for QA, and so far Alchemy supports a few popular Ethereum-based networks for these customized webhooks, right? So we have the Ethereum mainnet, we have the Gertie, we have Optimum, Polygon, Option. So those are for our QA testing purposes. So we end up have one webhook per blockchain. Then if you look at the list of webhooks we set for our production system, it all uses the same web endpoints, but we kind of partition the different contracts into different buckets, so we don't go over the limit supported by the Alchemy GraphQL query, right? So there's certain size limit for each query. So we end up creating many buckets for the Ethereum mainnet. And if I remember correctly, every single bucket we support up to 5,000 or 2,000 like contract addresses. Right? Then we also set up the WebSockets for other blockchains, and the Polygon is the second largest one. We have 3 buckets. Then for the rest, like we have Optimum, we have Option, then we have a couple of testnet there as well. So those are the input, and that express our requirement to the blockchain events we care, right? So let's just look at one of them. So we look at the GraphQL query we have, right? So basically the idea is, hey, for every single block, we try to fetch the logs by this EtherJS compatible filter. And in that filter, first of all, we give an array of contract addresses and say, oh, those are the contract addresses we care. So it's going to be a long list of contract addresses. So it aggregates all these contract addresses from the token gating rules we support for all test communities, right? So this is a very long list. Second one is the topics, right? Remember when we walked through the blockchain transfer events, we saw that items on the topic, right? Then we use this special syntax say, hey, we care about a couple of topics. So the first one is really the single transfer events. Then we have the batch transfer events for ERCs 1155 and the ERC 721. So we, as you can see here, it's a double array, right? So the double array actually translates into the ESET filter about all conditions. So basically, as long as the topics meets one of the event hash, we care. So that gives us the ability to listen all the different transfer events coming from different contracts. Right. So basically, 2 critical pieces of information. One is the addresses array. The second one is the topics filter. Right? So that's how all the magic happens. So that's about the walkthrough of the filter setup, and definitely will give kudos to our friends at Alchemy. So they really care about the use cases we have and work with us to drive the initial requirements and refine the implementation. So that's a game change for us. Yeah, so pause a little bit, going back to see how we implement it, right? So maybe I will show the a BD diagram first. So for us, we have information in our system, mostly for every single community when you invite the Collab.Land bar, when you have the community admin to set up the different token getting rules, right? So we have the information say, hey, for every single rule, it usually point to an asset. And that asset could be the different governance tokens you have for that community, which could be a fungible token or could be an NFT, right? So that's why we can figure out for any given community, are there any reference to this ERC20, ERC721, ERC155 assets, right? So that's one social choose. And as part of the process, we iterate through all the communities and build a collection of these relevant assets. So that will be translated into this list of chain ID and contract address buckets. Okay. And we filter based upon what Alchemy can support today, which is ECM, Polygon, Optimum, Option, including the mainnet and some of the testnets. So we only pick up the TGRs that refer to that different kind of chain IDs. Then, of course, for each of the TGR for that given ERC smart contract, we get the contract addresses, right? So this one becomes a huge list of candidates. Then we apply the partition algorithm. That for a given chain ID, if the number of if the number of contract addresses over certain buckets, then we basically just divide them into groups, and every single group will becomes one webhook we create against Alchemy. So that's where you see this huge list of different systems here, right, on Alchemy's side. So that's how we actually build up that webhooks, and we have to maintain that webhooks because the token getting rules can come and go, right? So at this point, we just have a cron job to periodically scan the latest version of the TGRs and refresh the webhooks. In the future, we can further optimize that and say, we use a Redis cache and we watch for the events that will impact the TGR. Say, community admin use our command center to modify the TGR, and if that has meaningful change to our watch list, we can update that watch list. So this way, we don't have to scan the database for periodically and build up that latest version of the chain IDs and the contract address and update the Alchemy customer hooks as we go. So that works out pretty well. So once we set up the webhooks, then Alchemy will do its job because Alchemy RPC provider, they watch the different block events, and based upon the contract address filter as well as the topics filter, it just start to emitting events by calling our API endpoint. So we have this specialized API endpoint, which is /Alchemy/notifications. And we have security in place to make sure it's coming from, Alchemy side. And then we also figure for this single endpoint where an event happens, what blockchain that event is happening, because at this point, the payload from Alchemy does not have the chain ID. So we need to map the webhook ID to the chain ID based upon this mapping, right? So if you look at the different webhooks, we have the webhook ID, then we have the network ID. So if we know the webhook ID, we know which blockchain that event happened. So that's how we map the system. So once we receive the event, and of course, from each of the event, we have this information. We have the contract address, right? And as we build up this candidate, we keep that cache in Redis, so we can quickly look out for any given contract address. What are the communities behind that contract address actually use that as a governance token? So that first identify the first dimension of the candidates, which are a list of community IDs that use that contract address. Okay. And secondly, what we care is, we look at the from wallet address and the to wallet address. Then we need to perform another reverse lookup from our member record. For this wallet address, are there any members have that connected wallet, right? If none of the members have that wallet address, then we don't care. We just throw away that event. So if we find a hit, then we end up finding a member. And now we get a list of communities and we get the member ID. So we will have iteration of all the different communities for this given member, right? So that will translate to the so-called, the blockchain events-driven approach. So that's how we schedule the balance check job and have Collab.Land to do the work in near real time. So that's for the BD diagram we have, right? So I actually skip some of the slides because when I talk, I kind of iterate through all the different things. So we have a cron job to get latest contract addresses for the spot chains and update the webhooks. And this is a screenshot of the blockchain, GraphQL Query we care. Okay. Then this kind of explains what happens when we receive a event. Then we kind of check the from and to match one of the connected wallet addresses, and we also look up the community that used the contract. Now, of course, afterward we'll schedule the balance check if there's a hit. And this is the BD diagram. I kind of illustrate how everything get pieced together. Right. So this is very much like the idea I want to convey here, and we are still improving the whole implementation and infrastructure. And of course, it only support a couple blockchains here, but these couple blockchains actually are representing majority of the token getting rules. If I have to make a guess, I think that's probably at least 80% of the traffic we deal with. And we'll incrementally roll out this feature to the communities. So stay tuned there. And we also try to figure out for all the blockchains how we simulate this approach. Say we have a Flow blockchain, we have Near blockchain, we have Solana blockchain. So we'll work with the different blockchain foundations and also working with the different RPC providers to see if there's an opportunity we can create a similar user experience like what we are getting here with the EVM compatible blockchains to transform the blockchain events into push notifications through our webhooks. And one of the things I like the webhook is because we have a horizontal scaling capability. So every single API endpoint is going to be supported by multiple server instances behind the node balance. So webhook give us that nice fit because any event coming, the node balancer will pick up one of the servers. So we won't, repetitively, redundantly process the same event, right? And we have that load balancing capability to scale up. So that's number one. Number two is if we use a traditional WebSocket, then we will have this struggle because we have 5 different servers behind the API pool, right? Like if we run the WebSocket connection to the RPC provider, we end up have the 5 events coming to the different server instance. Then we have to coordinate. Because we're getting this event 5 times across the board, and we only want to process that once. So we have to build some infrastructure to eliminate the redundancy there. And also, we are running the server by days, by weeks, by months. So have a non-running WebSocket is often troublesome because the network can go down and something could happen, then the WebSocket can get stuck in the middle. So we are pretty excited about the webhook-based, blockchain event push notifications and give us this nice infrastructure so we can further improve our token getting capabilities and optimize our infrastructure use. Right, so we turn the things around, and instead we proactively pulling the blockchain. Now we have the blockchain tell us what's happening there. So that's pretty much all the content I have today, and we still have a little bit of room. So I want to give people the opportunity to ask questions if there's any questions there.
Sounds good. So, for everyone in the audience, if you have any questions, please feel free to raise your hand in the stage and we can bring you up to answer to them. Or you can also write them down in the chats and we'll make sure to bring those up for Raymond to answer. In the meantime, maybe this is a good time to distribute the POAP. What do you think, Raymond?
Yeah, I think that's a good idea. Let's get the fun going.
Sounds good. All right, just 1 second. And we are good to go. Awesome. So, for everyone listening, if you would like to claim the POAP for today's CTO office hours, all you need to do is to use the slash command. You can write this down in the state chat or in any of the chats in the server, any of the channels. You can use any of them because we have it enabled in all of the chats. And what you will use is the slash command POAP claim. If you write slash POAP, you should see a drop down and you can select POAP claim. And then you will write down the claim phrase that is balance check, all lowercase with no spaces in between. That's the secret word to claim the POAP. Again, that's balance check. Those two words, all lowercase with no spaces in between. And then you hit enter and you will receive a code to claim your POAP. Please let us know if this worked. Again, the secret word is balance check, all lowercase with no spaces in between. Please let us know if it worked. Otherwise, we can repeat the word again if needed. All right, it worked for Anjali. Thanks, Anjali. Always super excited to use the POAP mini app. It's so easy. It's easy to set up and also super easy and fast to claim the POAPs. So it's for sure one of my favorites. Hey, I see people claiming the POAP. Awesome. Thanks, guys. Just in case, again, the secret word is balance check, lowercase with no spaces in between to claim the POAP. Awesome. Thanks everyone in the audience confirming that you were able to claim the POAP. That's always super exciting. And I don't see any questions right now. But again, one more reminder that if you have any questions, you can raise your hand and we can bring you up in the stage for you to ask your question, or you can write it down in any of the chats.
And thank you for joining, and we'll see you in 2 weeks. If you have any interest to listen on certain topics, you can raise your hand, let us know, so we can arrange the content based upon your need. We are doing a lot of exciting stuff here technically. We are also doing a lot of research projects. So over time, we'll surface them through the CTO office hour or even the dev real hours. So the door is open. We try to really build in public and see how it goes. We are pretty excited about the journey we have here together.
Absolutely. And also, I think it's worth mentioning that You guys can find the recording for this CTO office hours in our YouTube channel. So I'll link that real quick in the chat in case that you would like to go back to watch it again. And we'll also be posting it in our recordings post just in case that anyone missed it. You are able to find these and all previous and future CTO office hours in our YouTube channel. All right. I just sent a link in the stage so you can subscribe if you want to receive a notification when new videos are posted. And with that, I think that we're good to wrap things up.
All right. Thank you, Chibi. Thank you all.
Thank you, Raymond, and thanks everyone in the audience. It's always fantastic to have you guys here. And yeah, stay tuned to our next events and announcements in our announcements channel and events channel. We will see you all next time. Thank you.